everybody, and welcome back to the Microsoft Data and AI South Florida User Group. Thank you very much for making the time to be here with us. And today we have a fantastic presentation where you're going to be able to learn about Azure SQL Database with demos. And the presentation will be delivered by none other than Anna Hoffman. How are you, Anna?
Hey, Adriano, I'm good. I'm really excited to be here today. Thanks so much for having me.
Great to have you here. Can you tell us a bit about your career? How did you get here? How did you get involved with the product?
Yeah, sure. So I started almost 5 years ago at Microsoft right out of university in their consulting division. And then I made my way to the AI engineering team where I did a lot with development, bots, cognitive services, machine learning, that sort of thing. And then I made my way a little over 2 years ago to the SQL Server Azure SQL team. And that's where I've been for the past few years, focusing on enablement and a few other things, as well as customer retention. So I wear a lot of hats, as I think everyone can kind of relate to.
This is great, awesome. So tell us a bit about the presentation, what we're going to be seeing here, how it came about, how has it been your experience?
Yeah, definitely. So this is a newer session, one I haven't done many times, and so we'll see how it goes. But, I think slides are really great and really useful, and there's a time and a place for it, but sometimes you just want to see what the product looks like. So this session I put together, it's a bunch of demos. I think I have 15 demos. We'll see what we get through today, just to really show you how different things work, whether it's security, performance, availability, deployment and configuration, all these different aspects about Azure SQL that I think are good to know, but also show you, kind of how powerful being on a platform as a service in Azure can be.
All right, so will be a presentation where whether an individual is a beginner and or a more seasoned professional will be able to derive knowledge from it.
Yeah, definitely. And the coolest part is that every demo I do today actually has a corresponding exercise for free, which you can go try yourself. So if you want to go get hands-on with any of this or go deeper with any of this, I'll share that at the end.
This is awesome. So without further ado, take it over. Thank you.
Awesome. Thank you so much. I'm just going to share my screen. Can you just let me know when you can see it? Wonderful. And if anyone has questions throughout the session, go ahead and leave it in the comments, and we'll find times for Adriano to ask me those questions. Cool. So let's go ahead and get started. Like I mentioned, the session is going to be all demo based. I just have this one notepad to kind of give you a little bit of information and resources that we can walk through at the end. And like I was telling Adriano earlier, everything you're going to see today is based on this learning path in Microsoft Learn called Azure SQL Fundamentals. So we're going to take you through some concepts like getting started with Azure SQL,
like I mentioned,
deploying and configuring Azure SQL, security, performance, availability, and then some topics on how to kind of put all these things together into solutions. So we're going to go fast. We're going to have lots of demos, but I'm hoping that you'll learn a lot just by seeing. And later, if you want to get hands-on, you can also do that for free. So what I'm going to do is I'm going to start in the Azure portal. So hopefully many of you have seen all this before. This is just my recent resources, and then some other items. Now this you might not have seen before, this Azure SQL Blade. This is not that new, but it's relatively new. And what this allows you to do is group all your Azure SQL resources in one place. So what you can see here is I'm able to see the resource type, the service tier, and some other information. One of the really interesting things is it's not just SQL databases. It's also going to have my logical SQL servers, my SQL virtual machines, my Elastic pools, my managed instances. So everything is going to be here in one place for me to manage and monitor my SQL resources. Now I can also click New, And what that's going to do is give me a little what to use when between the Azure SQL deployment options. So if you're newer to Azure SQL, briefly, there are three main deployment options. There is a SQL database. So you can think of this as just getting a database. So if you don't need instance scoped features, then SQL database is going to be a great way to go. And this is the only option today that supports hyperscale and serverless, which we'll talk about during this session as well. Now, if you do need those SQL Server instance scope features, so things like CLR, service broker, machine learning services, SQL Server agent, then SQL Managed Instance might be where you want to land. And this is still a managed service, so you're still getting, versionless Azure SQL. You're still Microsoft is still taking care of things like backups, SLAs, availability, that sort of thing. But you do get a little more control than what you might get with SQL Database. And then finally, of course, if you just want SQL Server running in a virtual machine where you select the image, the version, all that stuff, even the license model, so if it's bring your own license or pay as you go, that is here as well. So today we're going to be focusing on Azure SQL Database. One big reason for that is it's really easy and quick to get your hands on. It only takes about 3 minutes to deploy, and it's also a fairly inexpensive resource. So let's start by creating an Azure SQL Database. Now in here, I'm just going to select the subscription I want to use here. You can see a few things right off the bat I'm deciding. So my subscription, my resource group, my database name, I'm just going to call this AdventureWorks. Probably you all have seen this resource before. And then for server, for Azure SQL Database, even though you're just getting a database, you still have to have something to connect to. So we have this idea of a logical server, and this is going to help you kind of group databases together and also connect to a specific database or a specific server. So I'm going to call this server just AW server, and we'll call it 03010 for the date. I must have already created that one, 0311. And then you're going to provide an admin login. You can think of this kind of like your SA account. You have to deploy with a SQL Server login account. So I'm just adding in a password that meets the password requirement. I'm selecting a location for that server, and I'm going to select OK. So now we can see I have my server. I can see if I want to use Elastic Pools. Now, if you're not familiar with Elastic Pools is a way to deploy many databases that share resources. So if you're a software as a service provider, or you have many databases that you want to cost optimize and share resources with, then this can be a great option. We're not going to use that today, but the final kind of big choice you have to make is around compute and storage. So let's take a look at some of the details in there. Now, in the vCore model, which is what I'm going to focus on today, there are three main options, and maybe you've seen some of these before. The main difference is that general purpose is going to be best for your general purpose, most business workloads. And then on the flip side, business critical is going to give you the highest availability from an SLA perspective, as well as sometimes the highest throughput or the fastest latency. And then kind of in the middle, as far as price goes, is hyperscale. And the reason we came up with hyperscale is this essentially gives you, in theory, limitless storage. So you can go up to 100 terabytes here. And for hyperscale, it's actually really interesting. We re-architected SQL Server to be a cloud native solution. So that's kind of how hyperscale came to be. And it's a really interesting topic. If you don't know a ton about hyperscale, I definitely recommend learning more about it. For today, we're going to stick in the general purpose service tier, and we'll talk more about these different service tiers when I get to my availability section of demos. But for now, we're going to stick to general purpose. You have two choices. You can basically use pre-provisioned compute, which means you have a set amount of compute that's allocated to you, and whether or not you use it, you will be billed for it, but it's always available for you. Now, the other model is the serverless model. This is one that's catching a lot of eyes and really gaining a lot of adoption recently. And what this allows you to do is basically independently scale your compute and storage, just like provision would do as well. But in addition to that, what it's going to allow you to do is set a minimum and a maximum number of vCores. So what you see here is I can set my min and my max number of vCores, and I'm only going to be billed for what I actually use, and we're going to bill you on a per second basis. So that means on a per second basis, this is going to auto scale between the min and max and only bill me for what I use. So this can be really great for scenarios where you have unpredictable workloads, maybe workloads that change over time or over the course of the day. And it can also be really useful if you have intermittent workloads. So if you have, for example, a typical line of business application where no one uses it at night or on the weekends, you might consider enabling auto pause. So in this case, after 1 hour of no activity on the database, what we're actually going to do is separate the compute from the storage and essentially shut down SQL Server. But during that pause time, you're only going to pay for the storage. So it's going to be really, really, really cheap. You can see just an example here of your estimated storage cost per month and then your compute cost per second. So depending on how often you're using this database, this could turn out to be a really, really large cost savings opportunity. So I just wanted to show you that during this. So that's kind of how you would go about figuring out your compute tier as well as your min and max number of cores. You can also change the configuration of the hardware. There are several different hardware options, but Gen 5 is also more kind of the general purpose type of option. All right, so let's go ahead and select. And we're going to go into the next blade. Now, this next blade is about networking. And this is something that, most data professionals don't think about a ton, but it's really important when it comes to Azure SQL because just like on-prem or wherever you're running, this is how you're going to connect to this thing. So the default is no access. And I don't recommend ever selecting this option because it basically means if you set this up, no one's going to be able to connect at all. So you're not going to be able to connect. No one's going to be able to connect from any network. The easiest option if you're just getting started is to use the public endpoint. And then there are two options in here. You can actually add a firewall rule for the IP address that you're connecting to. And you can also say allow other Azure services and resources. So this is going to allow any Azure service to be able to connect to or attempt to connect to your Azure SQL Database Logical Server. So this is the easiest way to get started to turn these options to on. However, there are some slight security concerns potentially here if you're running at an enterprise level. So I will show you how to enable the private endpoint. So setting this up is really easy. What I'm going to do is just say add private endpoint. It asks me for a little bit of information. I'm going to call this AWS Server 0311 PE for private endpoint. You can see the target resources SQL Server. There are lots of other private endpoint services available. It's not just an Azure SQL database thing. Next, I'm going to actually deploy this private endpoint into a virtual network. So basically, access to this Azure SQL database is going to go through a virtual network. So I'm going to select the virtual network that my virtual machine that we're running in right now is actually in. And I'm going to select the subnet. And then if I want, I can even integrate it with a private DNS zone. So pretty easy to set up. You just want to make sure that you're going to have access to it. So let me just get this back up. And so that's private endpoint. And I'll show you once it kicks off kind of the differences between public and private endpoint. Now yeah, sure. 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 Yeah, definitely. I think it's a great question, Adriano. Actually, just to kind of back up a bit, when we think really about general purpose versus business critical, what you're picking is the underlying availability architecture. So for general purpose, if you're familiar with SQL Server, you're selecting a failover cluster instance. So that's kind of how we're operating. We're going to deploy that for you in the back end. And for business critical, what we're going to do is we're actually going to deploy an always-on availability group behind the scenes. And so this means you're going to have 3 replicas additional replicas in addition to your primary at any given time. And one of those replicas you can use for read scale. So you can see from the price that it is more expensive than the other service tiers. However, it's going to give you that always on availability architecture. We're just going to deploy that for you.
All right, that's a great question there, Matty. I hope that Anna has addressed your concerns. And also we have one question from Gina, which is she wants to know, for the serverless option with auto pause, what is the approximate wake up time? For example, it typically takes 2 to 3 minutes for an Azure Data Factory SSIS IR to wake up. Is it similar for serverless?
Yeah, that's also a great question, Gina. So thanks for asking it. So what happens is when you initially, if it's paused, when you initially try to connect, that first connection will fail. But what happens then is we're going to, reconnect it and get it back up and running. And from my experience, it takes about 30 seconds. It can take up to a minute. One thing to keep in mind is that you are going to be starting out with a cold cache. Since SQL Server was shut down. So you might have a bit of a warm-up period to build that up again, but within 30 seconds to a minute, you should be able to start actively using it. Hopefully that helps.
Fantastic. And folks, just remember, any questions you have, drop on the chat window, and during a break, we'll come over and we'll address those questions. Thank you, Gina. Thank you, Matty, for the question. And back at you, Anna, please.
Awesome, thanks. And I happened to click some weird button that undid my deployment, but that's okay. We're just gonna keep rolling. So once you pick the networking, so in that case, remember we set up private endpoint. The next thing you can do is select a data source. So by default, there'll be no data in your database, which is what's typical. You can also choose to restore a database from any other Azure SQL database that you have, or you can just use the sample. Now, for a lot of learning exercise and POC and dev test, trying to understand how it works, I recommend just deploying with the sample. It's the easiest way to get started. Then there's also things like database collation and Azure Defender for SQL. Now, Azure Defender for SQL is a very important security capability that we will get to talk about a little bit later. So once you select the additional settings, you can basically go to review and create and go ahead and deploy this database. Now, like I mentioned, I reset my deployment, so we're not going to actually deploy this today, but that's okay. Before we get into the next section, I did want to show you what I was talking about related to private endpoint. So what I have here is it's the same server, just a different day, and this one's using a public endpoint. So what I'm using is NSLOOKUP, and what NSLOOKUP is going to reply to me with is information about the DNS hierarchy. So this is publicly available information about my Azure SQL Database server and where it's located and that sort of thing. So what you're seeing is you're seeing some things like CR4. So you're able to see the control ring that it's located in. You're able to see the region it's located in, ECS2. You have a public IP address. You also have information about the data slice. So these are things you might not want to be publicly available about your database. And so that's why earlier I mentioned, having a public endpoint is great. It's easy to use. But when you talk about security, you really want a private endpoint. Now I have another database server that has a private endpoint. You can see the difference here is just DR versus non-DR. But if I run the same command there, what we're going to see is quite a different answer. So what we're seeing here is just the name plus privatelink.database.windows.net. We're seeing a private IP address, which you can't really do anything with unless you're able to get into the virtual network where this is, and you don't know any information about that virtual network, and then the alias as well. So private endpoint from a network security, from a DNS hierarchy, is going to be much more secure on only allowing in connections through that virtual network, as well as limiting the amount of information that's publicly available. And one other thing to note about private endpoint is you can only connect to this database server. So you can't connect to this private IP address or this private link name. And the reason we did that, one of the big reasons, is so if you have a public endpoint enabled today and you choose to go towards private endpoint, you don't have to update any connection strings. We're taking care of that aliasing for you, so that can be really helpful. So let's go back and I'll just show you in that one database server I mentioned that does have private endpoint. This is the Azure SQL Database Logical Server. And on the left-hand side, what you can see is firewalls and virtual networks. And you'll notice that I don't have any firewall rules or virtual network rules configured because I am using the private endpoint. So you can see that private endpoint there. And once you have a private endpoint, you can check this box to deny public network access. Now, you only want to do this if you have private link enabled, because otherwise you're not going to be able to connect. A few other security things you can see, you can set the minimum TLS version. We don't set one by default, but we encourage you set it to the highest capability, which is 1.2 today. And yeah, so that's private endpoint. I'll take a pause. Do we have any more questions? Should we keep going?
Hey everybody, feel free to drop your question on the chat window, and remember to like the presentation, share, drop a comment as well, say that you like it, and let's take a look at the questions. We do have one here from Matty, who is asking, can you please explain about Elastic Pool?
Sure, yeah. So Elastic Pools is a deployment option which allows you to deploy multiple databases which share resources. So for example, here, I only have one database allocated per service. So for example, if I go down to here, you can see this is just one SQL database. I've provisioned it with 2 virtual cores. It's general purpose. And there's no sharing going on, right? The 2 virtual cores is dedicated to this database. Now, if I had an Elastic Pool, what I can do is I can put lots of databases in that Elastic Pool and configure how I want those databases to share resources. And this can be really useful for cost optimizing if you have a lot of databases that kind of fluctuate in their usage. Hopefully that helps.
All right, so pretty much is what you're going through here as through the sample is more of a managed services than Elastic Pools then.
Well, Elastic Pools and SQL Database they're both managed services. The difference is just whether or not you want to share resources between. So for example, I could put this SQL database in an Elastic Pool with a bunch of other databases and then choose how I want those resources to share. So really, I think Elastic Pools is great for software as a service applications. So a lot of vendors that are running these third-party applications, or if you just have a lot of databases and you were trying to cut down on cost.
All right, awesome. That's some great tips there. I see that the presentation you talked about the security as where you left off. You just covered the firewall and talking about the IP addresses, how it's set up for the private network. Good thing. So it's all you now.
Okay, awesome. So let's continue by looking at security. Now, once you've deployed a database and a database server, you might consider doing a few things. Now, the first thing, so what I'm going to do is go up to the server. The first thing you might consider configuring is an Azure Active Directory admin. Now, this is interesting, and many of our customers are using Azure Active Directory, but one thing to be aware of is that you can only have one Azure Active Directory admin. And in this case, of course, for this one, I've made it myself. But if you wanted it to encompass multiple people, then you could also assign it to a group. But in this case, I just assigned it to myself. And so let's think about what we've done. So we've looked at some of our options. We've picked some options. We deployed a database and a database server. We've enabled the Azure Active Directory authentication and the Azure Active Directory admin. I think now, like, let's take a look at how you're going to connect to this thing and also configure and add users and authenticate users just like you would in SQL Server. So for this, I'm going to switch over to SSMS. Hopefully this is a tool many of you have seen before. And I just want to show you all that right now I am connecting to that database server, AWS Server 0602. So that's the same one we've been seeing, the same one with private endpoint enabled. And I'm connecting to it using Azure Active Directory, so my AAD account. So this is very similar to what you're used to doing in SQL Server. There's just a few differences. So let's kind of walk through that. So the first thing I want to show you is creating a login. So in this case, I'm going to create a login in the master, which is similar to what you would do in SQL Server. And then I can connect to a database and create a new SQL user from that login in the database. And similar to SQL Server, until I give the user access to read or write data, they won't be able to do that. But I'm using the same T-SQL as you would use in SQL Server. Now, something interesting, an interesting concept to understand is this idea of contained database users. So this is the idea that I can actually create a user with a password in a database without first creating a login for him in the master. So this is known as a contained database users. And the reason I mention this is because it's very important when we talk about Azure Active Directory. But what this is going to do is Bob is only going to be able to log into this database that we're connected to, not all of the databases. So he's going to have to specify this database when he logs in, otherwise he won't be able to log in. So this is good as far as, limiting the scope. Now for Azure Active Directory, you only have the options of doing this contained database user. So for example, I'm connecting to the database and I can use this line. So what the new T-SQL is that you don't have on-prem is create user and then their Microsoft account or whatever organization AAD account. And the key new words is from external providers. So that's going to be for Azure Active Directory. And similar to before, until you give that user read or write access, they're not going to be able to do that. So this is really interesting, I think, because of how similar it is to SQL Server. So a lot of times when you think about moving from SQL Server to Azure SQL Database or Azure SQL Managed Instance, you can remember that, at the end of the day, it is just SQL. There are a few things that are different, but it's really just SQL. So that's authentication. Now, the next security topic we're going to talk about, we're going to just keep going into it, is auditing. So here back in the portal, you see there's this auditing blade under security. And for Azure SQL Database, there's this thing called Azure SQL Auditing. Now, this is exciting because two of these things just went generally available last week at Ignite. Those two things are the ability to write your logs to log analytics, and also the ability to write to event hubs, and the ability to audit Microsoft support operations. So what does that mean? That means that if you open a support ticket with Microsoft and Microsoft has to do something related to your database to help you solve the problem, you're going to be able to audit what they do if you turn this on. So what you can see here is I've set this up to go to storage. So this is just an Azure storage account and a log analytics account. And we'll take a look at what both of these look like. But basically, this storage account is just where I'm going to store those XEL files. So that's auditing. Now, what I'm going to do is I'm going to go back to a specific database. So we'll go back to the database we kind of been looking at all this session. And if I go down to the left under security, I see a few other things. So data discovery and classification is the first one I wanted to talk about. Now, this is something that's available in SQL Server as well. One of the main differences is that for Azure SQL Database, you can do it in the portal and you also get some recommendations. So you can see I've already applied all these recommendations. The one I wanted to call out is the first name, middle name, and last name, because that goes with this next demo we're going to do. So what you can see is I've classified this information as confidential because of GDPR. Now I have different options that I can put in here, whether it's public, general, highly confidential, what type of information type. But I want to note that these all came from recommendations, so I actually didn't have to put in any of this. I just ran the recommender and then it pulled this out. So what this is going to do is it's going to associate with this data, this metadata saying, hey, this contains sensitive information. This is the information type that it is. So this is a very interesting thing, and we'll see how it surfaces. Now, the other thing I wanted to show you all is dynamic data masking. And again, this is something that is available in SQL Server today. Again, you're going to get recommendations here. You can see I've already added some of those. Adding these masks is really simple. You basically say what you want the mask to be called, the schema, the table, the column, and how to mask it. And you see you have some different options, whether or not it's a credit card, an email address, maybe you want to do a custom way, or the default value. So it's just going to go to X's. Okay, so now that you've seen that I classified some sensitive data related to names and I masked some sensitive data related to names, let's see what that kind of amounts to in a demo. And we also configured auditing. So those are the 3 things that we did that are really going to help us get a full picture on what's going on. So I'm going to switch back to SSMS and look at this masking tab. And at the end of this demo, we'll take some more questions. So be sure to get your questions in there. Okay, so masking. So we're connecting to the same database we've been using where we enabled the data classification of that sensitive data for the name. We also enabled dynamic data masking, and we also have auditing for log analytics and storage turned on. So let's see how this results in a real world scenario. So first, I just want to look at this table. So I'm looking at this table and I'm able to see the first name, middle name, and last name. Now I'm connecting as me. I'm the Azure Active Directory admin, so I'm able to see all this information. Now, if I wanted to create a new user, and I always create my new users as Bob. I don't know if you all know Bob Ward, but we work very closely together, and he's a very big Dallas Cowboys fan, and I am a Tennessee Titans fan, so I always throw in some Titans joke. But anyway, so what I can do is I can go ahead and create Bob as a user. We'll see if I haven't created him already. Yep, so we can create Bob as a user, give him access to read and write data, just like we talked about in the authentication demo. And now we can use this T-SQL execute as to kind of pretend like we're Bob and see what he can see. So now I'm going to go ahead and execute as Bob. And what we can see is Bob does not have access to see this masked data. So when he queries this data, he's just going to see the masked field in this case, which is just X's. And then I'm using this revert to say, okay, we don't need to be Bob anymore. Now, what I can do if Bob needs access to this is I can use this T-SQL grant unmask. So now I'm going to run this. I'm going to grant unmask to Bob, execute as Bob, and now you can see that Bob is able to see everyone's names. So if he needs to be able to see this, then he can. Now, finally, if I want to remove that unmasking from Bob, because for whatever reason he no longer needs access to this, I can use revoke unmask. And now if we execute Bob as one more time, again, we're going to see that he's not going to have access to see this data. So what you can see from this is that that masking is going to apply by default unless you're an admin. So now that we've done that, you might say, okay, that's cool, Anna. You showed me how I can see the masked data and how Bob isn't going to be able to see the sensitive data. But how can I track access to this sensitive data? So this is where it gets kind of interesting and we start to combine a few things. So what I can do is I can click open and I can click merge audit files. Now, normally for SQL Server, I would add them from local disk. But since this is running up in the cloud, I have to add them from Azure Blob Storage. So I'm just going to sign in. We'll see if it prompts me for my code. That's interesting. Let's try this one more time. And let me just authenticate. So this is multi-factor authentication. So I just have to log in on my phone. Okay, so now that we're able to connect to the subscription, what we're going to do is we're going to select the storage account, which you might have seen earlier, where I'm actually storing those log files. So this is going to be the XEL file. So I'm selecting the storage account, selecting the SQLDB audit logs container, and let's say we just want to go from today, from this server, from this database. We'll just go from yesterday, even though it's only today. We'll hit OK. We see how many audit files there are to download. And we will go ahead and download them. And now we can open them. So now what you're looking at is those X event files. And you can see a few things in here: the timestamp, the instance name, the database, the server principal from who's connecting, the statement that was run, lots of information here. So what I'm going to do, and maybe I went back a little too far, what I'm going to do is I'm going to try to find one of those queries that we did with Bob. So for example, if I just bring this up, what we can do down at the bottom is we can see that query. Let's just make it. So this is when we were granting unmasked capabilities to Bob so that Bob could see the masked data. But what's really interesting here is there's this column called data sensitivity information. So because we classified this data, so not just masked it, but we also classified this data, we can now audit access to sensitive data, and we can see information that it was medium, that it was confidential GDPR, and lots more information about that sensitive data. So really the combination of data classification, dynamic data masking, and auditing can be really, really powerful. And then on top of that, you could even add something like always encrypted for really sensitive data, for example, like social security numbers or something like that. Now, you can also see this in the Azure portal using log analytics, because remember, we set up log analytics. So I'm not going to go too much into it, but I just wanted to show you what that might look like. So I can get the SQL Security Events, and we can see here that same information, except now we're using log analytics. So here I see the data sensitivity information here as well. So with that, I'll pause there. That was one of the security demos. We have one more security demo, but I'll just pause there and see what the questions might be.
Hi, Anna. Yes, we do have a question here from Al. And he wants to know, can you start up the server on a schedule after an auto pause?
Sure. So I'm assuming this is for a serverless database, because serverless databases are the only databases that you can set to auto pause. And I guess the question is, can you schedule? So for example, let's say I know no one uses the database from 7 p.m. to 7 a.m. Is there a way that I can kind of pre-trigger this database to wake up at a certain time? And the answer is yes, but not as directly as you might be asking. You can't like set the schedule like, hey, turn this thing back on at 7 a.m. What you could use is you could use some form of Azure Automation. You could use an Elastic Job, and an Elastic Job is basically a way to do agent jobs on Azure SQL Database. But you could basically create a job that would, hey, go ping this thing at 7 a.m. So that it doesn't fail and it starts going. And maybe you even want it to run a few queries so it kind of pre-populates that data, since you are starting with a cold cache. So the answer is yes, you can definitely configure something like that, but no, it's not necessarily built in the way that you might think, or the way you might be suggesting. So hopefully that helps.
All right. So I hope that the question has been answered here. And folks, if you have any more questions, feel free to drop it at the live chat. Also remember to like, subscribe, and comment. And thank you, Anna. It's all you now.
Awesome, thanks. And keep the questions coming. It really helps. It gives you guys a break from hearing me talk. You get to hear someone else talk, and hopefully you get your questions answered too. Okay, so we talked about auditing. We talked about dynamic data masking. We talked about data classification. There's still two more security things I want to show you before we get into performance and availability. So if I go to Security Center, I'm going to see a few things. So for example, I'm going to see some recommendations, I'm going to see some security alerts, and I'm going to see some findings. So let's talk about what these are. So these recommendations are coming up for my SQL servers all up. So we're seeing things like, hey, take a look at vulnerability assessment, which we're going to talk about in a second. Your audit retention, you might want to consider increasing that. Since you're using the private endpoint, which we saw earlier, you should disable public network access, and you can see all sorts of more stuff here. Now, what you can also see, and I triggered this right before, and in the exercises which I'll share, you can see how to trigger a potential SQL injection alert as well. But basically, what this is part of Azure Defender, and this is going to pull up any alert. So it's able to detect a lot of different types of alerts, but you can see this alert I can click into. It's a potential SQL injection, and I can see more information about it. I can click view full details. I can see what the vulnerable statement was. So if I want to see, so you can see it's kind of triggering like a SQL injection. I can see what IP address connected to it, what application, how to investigate it. I can see more information. I can see how to fix it. So you can see there's a lot of ways for you to kind of understand any security alerts. And I also want to add that this happens immediately. So I fired off this query and immediately I got this alert. So that's also really interesting, really great to know that you're protected with Azure Defender for SQL. So that's the security incidents and alerts. And the last thing is vulnerability assessment findings. So what you can see is there's a lot of different tests that are run. Well, let me see if I can get to it. Let's see, give me 1 second. I'm just going to go to a specific database and we'll look at the vulnerability assessment. Let's see, here it is. So this is vulnerability assessment. And what this is going to do is this is using lots of different tests. You can see it's using 34 different tests that are based on various security and compliance certifications. And what it's doing is basically checking those and letting me know which ones have passed. So I can see which tests have passed. I can see which ones have failed. And I can even set this up to run on a schedule. So if anything changes, I can be notified that as well. And so, for example, if you have something here, this one is basically saying, hey, set a fixed high impact database role. So basically make this the baseline so that when we scan, if there's anything different, we can alert you of that. And it gives more information like which benchmark, the FedRAMP, for in this case, how to remediate it, and how to kind of see why this rule is being triggered. So a lot of really great security information here as well. All right, so that's security. We've talked about a lot of different capabilities in the security suite. TDE is the one we have not talked about. This is on by default for new databases, but you do have the option to turn it off, which we would recommend against. And you also have the option on a server level to set up something like bring your own key. So if you want to manage the key rotation instead of letting Azure manage the key rotation, that is an option as well. All right, I'm going to take a breath. Do we have any more questions, or should we go on to performance?
Sorry. We have here a question from Matt. He is asking, what is SQL Data Sync?
Yes, SQL Data Sync. So this is something a little outside of the topic for today, but SQL Data Sync is a way that you can keep certain objects that aren't in SQL database in sync with other databases in other locations. And this is something that is supported in Azure SQL Database today, but I'm not sure exactly how much further you want me to go into it. But yes, SQL Data Sync is supported in Azure SQL Database. There are some references that I can share with you at the end, unless there's a specific question.
All right. We also have a question from Al. Whoa, hold on a second. Oh, no, you answered that question. He retracted the question. So we have another one here, which is there an advantage or any advantage of a SQL managed instance with multiple databases versus Azure database sharing on a pool?
Yeah, that's a great question. I would say this is kind of the classic answer. It depends on what you're doing. So if you are using SQL Server instance scope features, so things like CLR, Service Broker, Machine Learning Services, SQL Server Agent, any instance scope capabilities, then you're going to want to go to Azure SQL Managed Instance, because none of those things that I just mentioned are supported in Azure SQL Database, because you're just getting a database level. So if that's where you're headed, then Azure SQL Managed Instance is going to be the best option. For elastic pools, for databases and elastic pools, this is going to be, I think, if you don't need those instance scope features, this could potentially be a way to cost optimize there. Now, not to throw you for a loop, but in addition to Azure SQL Managed Instance, there are also these things called Azure SQL Instance Pools. So if you want to put a bunch of managed instances together and have a lower minimum vCore required amount, then you could consider an instance pool. So I think really the first decision point is, do you need Azure SQL Managed Instance, or is Azure SQL Database sufficient? And then kind of go on that fork, whether you go towards elastic pools for Azure SQL Database or instance pools for managed instance.
All right. And we have one more question here from Matty. Can you suggest Azure Active Directory Identifier?
An identifier. I'm not sure I understand.
Yeah, that's not clear to me. So, Matty, take a minute and just elaborate on the question there, what it is and how you're going to use that, so you can give some more context to the question, and on the next break we'll circle back to you. Is that okay with you, Anna?
Yep, sounds good.
All right, so it's all you there.
Okay, all right, so the next thing we're going to look at is performance, and this is kind of an interesting one. So what I'm going to do is I'm going to go back to SSMS, and I have this script here of a few different commands. Now this first one is basically joining two very important views, which you can use, DMVs, which you can use to monitor what's going on. So the first is DM exec requests and DM exec sessions. So if we just take a look at this first one, what you're going to see is the session ID, the status. So what we want to see, especially when we're running a workload, is things that are running, right? If things are runnable, it means they're waiting on something. So what we see is we're not really doing anything right now, but we do have one thing running. And we can also see the wait type, the wait resource, and the wait time. So that's one really useful thing when we think about performance. You're talking about monitoring your usage of SQL database. This is one thing that's going to be really useful. And then the other one, which is useful, is DM DB resource stats. And there's a similar one for Azure SQL Managed Instance. But for DB, what this is going to do is it's going to say the time. So you can see every 15 seconds, this kind of logs an item. It says the average CPU percent, log write, data IO, memory. So this is going to help you understand what your workload is doing. You can see other information like the CPU limit. So right now this database is only allocated 2 virtual cores. And so there's a lot of information in these two views that you can see. And then this final one I added, this one's not necessarily relevant to Azure SQL Database, not as useful, but what you can see here is I have a 2 vCore database. So what you can see is I have 2 cores that are online. So these are allocated to me. The reason I mention this query is if you're running a serverless database, you can actually see how many of those cores are actively being used at a given time. And you can see the seconds of usage, or in this case, the milliseconds of usage. So with serverless, remember, you're billed on a per second data basis, so this can be really useful for that. But for me, when I'm looking at a normal Azure SQL database workload, these are the two queries I check first, especially if I'm hitting any issues. So what we're going to do is I have this workload, and it's basically using OStress to simulate a workload on this database. So I'm just going to kick off the workload. We can see that 10 threads were created, and we're beginning the execution. And what I'm going to do is I'm just going to run this and see what our results look like. So I'm running this, and you can see a few things. If you look at the first one, we're seeing a lot of runnables, which means we're having to wait. And only one running at this point. We're seeing a lot of SOS scheduler yield wait types. So basically, we might be able to say, okay, maybe it's a CPU issue. So if I run this again, what I'm going to see is, sure enough, this second query, the DMDB resource stats, is showing me that I'm hitting kind of the max percentage of CPU. So I'm going to start getting throttled. And that's why I'm seeing these wait types, these runnable. And you can see that that happened twice. We were kind of throttled twice. And now you can see they're all gone, which probably means our workload is over. So let's go check it out. We can see it took about 42 seconds to run. So just keep that in your mind. It took about 42 seconds to run. Now we could come back to this and say, okay, what are some other tools that I have to understand this? Is this a CPU problem? Is it a tuning problem? Is it something else? We kind of think it might be a CPU problem. So what I can do is I can use the query store. Now in Azure SQL Database, the query store is on by default. So this is really to your benefit, so you can just take advantage of this immediately. Now, what I'm going to do is I'm going to use top resource consuming queries. So what I can see is this query 286 is really taking a lot of the time, and you can even see the query text. So this is the query text of the workload that I'm putting on. And I can see how many times it was executed and the plan and other information. Now, if I wanted to go even more details, I can look at the query wait statistics. So if I take a look at that one, I can see that most of the time we're spending waiting on CPU. And I can even double click into that, and I can see not only that, but it's all coming from this 286 query. So that can be a signal to me that maybe I need a little more CPU for this query. You can see the average wait time is 1.62 milliseconds. So this is really interesting. The query store is really useful into getting insights about what's going on with your workload, so you can optimize for performance and know when to scale up. So what I'm going to do now is I'm just going to flush the query store so we can look at it again later. And I'm going to run this other query from DM user DB resource governance, and it's going to tell me information about what's deployed. I'm also going to go ahead and run this one, but I'll talk about it in a second. So let's go back here. So what we can see is the slow name. So the slow is the service level objective, and it kind of contains everything. So it's a SQL database, it's general purpose, it's using Gen 5 hardware, it's using 2 vCores, and we can also see that information here. So 2 CPU, the max memory, the max size, so all the maximums that we have there, the IOPS that's supported, that sort of thing, all here. Now, what I ran after that was this alter database command. So if you're familiar with SQL Server, you're probably familiar with using this alter database command. In this case, you can actually use it to scale up the service objective. So I'm going to scale up to a general purpose Gen 5 hardware 8 vCore. Now this was, I did go ahead and kick that off before I explained it. So now what I can do is I can check the operation status using DM operation status. And what you can see is I have a few here, but I have one that's in progress. So that's this alter database. We can see if it's complete, when it started, when it was modified, and we can use this to check the status of that. So let me just bring this back over. We'll take a look again, see if it's completed. It has completed. Now in the Azure portal for this database, I would also see right here that it was updating, but you can see here it's already updated and it's now an 8 vCore database. So we scaled it from a 2 vCore database to an 8 vCore database using T-SQL. So what we can do now is we can go back to that workload. Now remember, this workload took 42 seconds before. We're going to run the same workload, and we're going to see how it runs and what our wait types are like. So I'm going to go ahead and run it. I'm going to go back here, run our query, and what we see is a lot more runnings than runnables. We still have a few runnables, but a lot more runnings. We can see our average CPU is a little bit lower, and you know, these are still running. We still have a few wait types, so maybe you could scale it to more if you wanted to, but we can see we're not getting throttled here, and it looks like this workload has already completed. So let's go see. Sure enough, it took 17 seconds as opposed to 42 seconds. So one way you can increase your performance, if needed, is to increase that CPU that you have available. So before the second part of the performance demo, I'll take a pause. Adriano, what questions do we have that I can help with?
All right, Anna, let me take a look here. I know we have a couple. Let's okay. I'm not quite clear on, so Matty elaborated a bit, but it's still not quite clear. He said create users. So the question was, can you suggest Azure Active Directory Identifier? Then he elaborated by saying create users from Azure Active Directory identities. So I don't know, may be the case where he may want to say when an Active Directory identity can be created by for an application to access SQL database. That's what I'm trying to derive here.
I think maybe he's asking about manage identities, and that is a thing. So I definitely recommend like just go do a quick search on Azure Active Directory managed identities. So that is an option that you can have if you want an application to be able to connect to your SQL database.
All right. So we also have another. So Matty, thanks for your question. We have a question here for Gina. Hey Gina, thank you very much for your question. And her question is Query Store automatically enabled in Azure SQL? And if so, how much control do you have over its retention?
Sure, that's a great question. So yes, Query Store is on by default in Azure SQL Database, and this is really, you know, our performance and our experts decided that this is going to be the best thing for our customers. Now, if you want to flush it, you can flush it as frequently as you like. So I think that probably addresses what you're asking. You do have some control over what's happening in the Query Store, but we do have it on by default.
All right, I hope I'm great. I hope that I'm pronouncing the next person's name correctly. It seems to be Fahan. And Fahan, he wants to know if you scale up, all current connections are lost?
Yeah, that's a great question. So what happens when you scale? So this is really important actually, because when you move to the cloud, you need to build in this resiliency to your connection. So basically you need to have a system in place, and many drivers support this for SQL already, that basically has retry logic built in. Because what's going to happen when we scale you up, we're going to deploy those resources for you, get the data moved over, and during that time, you're connecting to your current resource, right? Now, in the few seconds where we fail you over, where we switch the connection string to this new database, you might momentarily not be able to connect. Now, your connection string isn't going to change, but momentarily you might not be able to connect. So you want to make sure you have retry logic built into your applications so that it will try again. And so a few seconds later, when it comes back available, you're able to connect. And I think it's a great question. And we actually have a demo that will kind of show you what I mean by that in the availability section, which is the next section. That's fine. We can take one more.
All right, we have another question here from Matty. He says that we saw CPU issues on Query Store. We have CPU vCore. We have added the vCore. If the vCore is not available, what should we do to fix this CPU issue?
Well, unless you're hitting the max number of vCores, you should always be able to add more vCores. But if you're hitting the max number of vCores, then you might consider looking at some other things and trying to see how else you might be able to optimize that workload. Or, potentially maybe run whatever it is that's hitting that limit. You could potentially try running it at a time when other things aren't running. There are a few things you can do. I'm going to take that as a good lead-in for the next part of the performance demo. A big part of this is monitoring performance, right? And so in the Azure portal here, you can even see where we recently hit the 100%, and then we scaled up and we ran the workload again, and we only hit 74%. So this is really useful just to see this. There's other information here. Now, what I want to show you is another example. So in the database down on the left, you have this whole intelligent performance section. And a lot of this is built on the query store, but a lot of this is also built on custom stuff only available for Azure SQL Database. So this is kind of the performance overview. So you're going to see a few things here. So let's just click into a few of those. So I want to start by looking at Query Performance Insight. And what this is going to do is it's going to show you the top 5 queries based on different things. So CPU, data IO, log IO, and I can even see into these. So I can click into this query that's, you can see it's taking 64% of the compute, and I can even click into it, and we can see things like what the query actually was that's causing this challenge, what it's happened over time, how it's changing. So there's lots of information. There might be some recommendations. There might be some settings. So that's something that can be really useful to see interesting things, see long-running queries. You can take a look and dive into those, and even set up your own custom type of aggregations and charts. So this is really useful. Now, one other thing that's useful is this idea of performance recommendations. So what you see here is we see some history items and some recommendations. So this is specific, these auto-tuning capabilities are specific to Azure SQL Database, and they're basically looking for, based on your workload, hey, we think maybe you could create an index. And if I click into that, I can see, what the impact is needed, disk space needed, the table, everything about the index type, so it's non-clustered. I can view a script that will put that index will create that index, and I can also choose to apply it and automatically apply these in the future. So what does that mean? It means if I decide to apply it, it's going to go into basically the queue, and we're not going to apply it right away. We're going to wait, because we understand your workload. We're going to wait till a time of low resource utilization and then apply the create index. And once we apply the create index, we're going to monitor and make sure it actually did result in an increase in performance like we thought it was. And if it doesn't, we'll roll it back. So this is a really awesome capability, and you can even set this up to be done automatically. So you can see I've got force last good plan set to on, but I can also set create index or drop index to on if I want. Now I can set them to off and just see what recommendations come up and then implement them myself, or say you can implement them. But if you're managing a lot of databases, this can be really useful to just help have a smarter database. So that's the last piece of the performance demo, I believe, just checking my notes. And the last part of the demos, these are kind of the cool ones, and we're going to talk about availability. Now, before we get into that, I do want to remind everyone of 2 things. So when we talked about Azure SQL Database, we talked about how there are 2, commonly used deployment options: general purpose and business critical. And general purpose is less expensive, so you can take a look over here. Of course, it's just for a certain region, and compared with business critical, which is a multiplier of cost. But the reason for that is really because of the underlying architecture. So underneath general purpose, like I mentioned, we're going to deploy a failover cluster instance. So that means, when we fail you over, we have to look for a node with spare capacity, fail you over, redirect the pointers, get you back up to being connected. So a failover can take, 30 seconds. And this failover can be forced by you, which is what I'm going to do in a moment. Or if the service says, hey, something's up, we need to fail you over, this is unhealthy, we need to fail you over, it can take about 30 seconds. And again, that's why retry logic is really important. Now, business critical, on the other hand, underneath, we have an always-on availability group. So when a failover has to occur, we already have 3 secondaries standing by that are ready to go. So we can fail you over much faster because we just have to redirect you to one of the secondaries and you're back up and running. So I've seen this happen as fast as 2 seconds, but it usually happens in less than 10 seconds. Again, retry logic is important, but this can be helpful as well. So what I like about this demo, and hopefully it will work for us today, I'm going to use Azure Data Studio for this one. So if you haven't seen Azure Data Studio before, it's a really great tool. It runs on all OSs, whether it's Mac, Linux, or Windows. So unlike SSMS, it runs on all platforms. And it has this notebook capability. So there's a lot going on this screen, but basically I have 2 notebooks. And a notebook is really great because I'm able to mix text and code. And if you've worked with Azure Synapse or machine learning, you're very familiar with these sorts of things. But we have kernels for SQL, Spark, Python, and PowerShell. So I'm a big fan of PowerShell notebooks, also a big fan of SQL notebooks. But let's talk about what this notebook does. So basically, I'm using Azure PowerShell commands to invoke a failover. So basically, I'm going to force a failover. And the difference between the right side of my screen and the left side of my screen is that the right side is a business critical database. So again, always on availability group, should be a fast failover. And the left side is a general purpose database. So failover cluster instance should be fast, but not as fast as the business critical database. So what we're going to do to run this test is I have 2 O-stress workloads. So this is hitting the business critical database, and it's basically just querying to see for availability. So if you see 847, it means the database is available. Now I'm running that same query, but on a general purpose database. So you can see general purpose over here. So I'm running the same query. And again, we're seeing the same result, 847. So we're just trying to see, is the database available? Is it there? Is it there? Is it there? All right, so now what I'm going to do is I'm going to try the best that I can to keep these off at the same time and just watch, again, the right side business critical, left side general purpose, and we'll watch to see how fast these failovers take place. All right, let's see. Okay, so once I kicked it off, you saw almost immediately the business critical database became unavailable, and there you have it. We're already back to being able to connect to that business critical database, which is expected because it's got that always on availability group. We're just redirecting the pointer, so it happens really fast. That was great. General purpose, on the other hand, takes a little bit longer because we don't have this secondary standing by. So we have to go look for a node with spare capacity, move the pointers, load up the data, and then fail you over. So what you're seeing, and usually it takes less than about 30 seconds, maybe, and there we go, it's completed as well. So both times are really fast if you consider I didn't set up a failover cluster instance and I didn't set up an always on availability group. I just deployed this and that's what I got. So really cool. I think it's really cool. I get excited every time. But this shows you how fast failovers can be. And it also shows you how important that retry logic is, because for the business critical database, it was only unavailable for like 2 seconds. But if your application wasn't built properly for that, you could enter this broken state because of a 2-second kind of blip. So that's something to keep in mind. Now I have one more demo left. I know we've been doing this a long time, so I have one more demo, but before that last demo, I can check in one more time for questions.
All right, folks. Remember, drop your question at the live chat so we can see what's on your mind. Also, drop a comment here. I believe you all enjoying the presentation by Anna here, so write a comment, support the channel. And Anna, very interesting, the last notebook execution just did with the failover comparing business critical, showing business critical users. Very cool. So if you all or anybody has an application out there, let's say is doing vital transactions where you don't want to lose, meaning there is no failback for it, this is a great opportunity to implement that solution there and know from the beginning how to set up your Azure SQL database there.
Yeah, definitely. All right, cool. So let's get in last demo. This last demo is about...
We do have one more question here. So let's take a look at the question. We have Farhang asking about, can we move from one tier to the other?
Yeah, that's a great question, because sometimes you might want to move or scale up or shift based on what's going on, the time of the month, the workload that happens. So yes, you can move freely between general purpose and business critical in Azure SQL Database and Azure SQL Management Instance. You can move back and forth fairly easily between business critical and general purpose, between provisioned and serverless. The one caveat that I'll say is today, moving to hyperscale, so remember that's the one that gives you unlimited storage and has been re-architected for the cloud. Today, once you go to hyperscale, you can't go back. So that's something you really want to be careful of. Make sure you plan for that. But apart from that, yes, you can go back and forth. And even going from hyperscale to other service tiers is something we're working on.
All right, great question there. Now, don't see any other questions. And folks, remember, drop a question, drop a comment, and any questions there, just live chat. Thank you. It's all you now, Anna.
Awesome. Thanks. Okay, so we have one last demo. This demo is about auto failover groups. But actually, before we go into that, what I want to show you is you kind of have different options when it comes to your databases. So what you have, the one option you have is called geo-replication. So geo-replication allows you to replicate your database to other regions. So what you can see here is for this database, I do have some geo-replication enabled. I can simply click a region if I want to add another region for my database. I can have as many geo-replicas as I want, and I can use all of them for read scale. So this can be really powerful. Now, one thing about geo-replication is that you don't get an automatic failover. So if you wanted to use this as like a failover group or something like that, that's not what this is. I would say this is more about, because you would have to update the connection strings, you would have to do the failover yourself. However, this is a great way to deal with replicas and kind of replicate where your users live. What I wanted to show today is failover groups. Now, what this is on a server basis. So it's going to replicate all the databases in a logical server to one other region. So you only get to do it to one other region, but we do have the automatic failover capabilities. And what's really interesting is what you see here is you're not going to connect to these actual servers. So these are the servers we've been using all day today. You're not going to connect to those servers. You're going to connect to the failover group. So you're going to connect to either the read-write listener or the read-only listener. And the service is going to take care of routing you to whatever the primary, or you see this case, the secondary is at that time. So that's failover groups, really, really great. You can also force a failover, and you can edit your automatic failover capabilities. So you can see the read-write failover policy is automatic, and there's a grace period of 1 hour. So we have this here. I basically have my main server. So this is my primary server in East US. And then I have what I'm calling a DR, or a disaster recovery server, in East US too. And that's my secondary. So that's the primary secondary right now. And what I also have is an application. So I have this application. It's a very simple Java application. And what this application is doing is it's basically trying to insert a row on the read-write listener endpoint, so this read-write listener endpoint, and then it's trying to read that row from the read-only listener. So it's only connecting to these two listeners, but in the back end, it's, you know, respectively inserting on the primary and then reading from the secondary. So it's just going to tell us if it's successful or not. So we can see, you know, insert on the primary successful, read from secondary successful. Now what we can do, and again, this is another PowerShell notebook that I'm using, is I can actually force a failover. So for example, first I can use PowerShell to basically get the replication role. So we saw it in the portal, but you can also see it in PowerShell now. So I can basically say, okay, this DR server, what role is it in? So right now it's in the secondary role. And again, in the portal, we can see that the DR server is also in the secondary role. Okay, so now what I can do is use this switch command. So I'm going to kick it off, and this switch command is basically going to promote the DR server to the primary server. Now, if I go back to my application, what I'm going to see is these inserts and reads are failing, right? And that's while this failover is taking place. I can also see in the portal, usually you can see that oh, you saw it swapped really fast. So now the DR server is in the primary role. And so we would also expect my application to be back to being successful. It's still failing. Again, while this redirection is happening, it fails for a few tries, but now you can see it's going back to being successful. So even though we're connecting to a different server, because we're using these read-write listener endpoints, we don't have to change any connection strings. Our app can just continue to run. So this is another great capability. And like we talked about earlier, this is another reason why it's so important to have retry logic, excuse me, in your applications. Now, I can run that same replication role command to see the status of that DR server. And again, we can see, we saw it in the portal, but we can also see here that it's primary. And I can also fail back the same way, except this time I'm going to promote the regular server to be the primary. And we'll see that, again, this will fail a few times and then it will become successful. So that's my last demo for today. This one's about availability and disaster recovery. We have done so many demos today. I want to just give you a look at some of the things that we've done, and they're all here. So we talked about deploying, verifying. We talked about some of the networking pieces, which are here. We talked about configuring auditing, also securing your network, Azure Defender. So you saw the vulnerability assessment. You saw as well as the Azure Advanced Threat Protection. So when we triggered that alert, we saw data classification, dynamic data masking, SQL audit. We did some performance exercises. We did some availability exercises, including looking at general purpose versus business critical and auto failover groups. And so we've really done a lot today, and I hope this has been useful. I hope you know that if you want to go deep into any of these or try any of them for free, this is the place to go do it. I have just 2 resources for you all here. This first URL is going to take you to this Azure SQL Fundamentals Learning Path, which is free for you to complete as many times as you want. You get like a 4-hour Azure sandbox, and when the 4 hours is up, you can just spin up another one. And the second one is the YouTube page. So the Azure SQL YouTube page, shameless plug here, host Data Exposed. So we stream live every Wednesday, and we also release episodes on Thursdays. So would love to have you guys join the show or watch our episodes and let us know what you think. I really just want to thank you all for sticking with me. I know this can be a lot to see all these demos, maybe a bit overwhelming. I hope it was useful. I'd love any feedback or any additional questions that you might have. And thank you, Adriano, so much for letting me come speak to you all. Oh, sure. Let's see.
Hello everybody, please take a minute, drop your questions here on the live chat. Still have a minute here before we come to a closure. I would like to thank Anna. Thank you very much for this awesome presentation where we are all able to see a lot of the capabilities for Azure SQL Database, from getting the all started, bring it online, in-depth coverage of the security aspects, providing us all a better understanding how to protect. Also, the performance piece, very, very cool, very important, on not only how to identify, how to address, and resolve any issues that may come. Remember, some of those practices, like query storage, does not only apply to SQL database, to Azure SQL Database, but also to SQL Server, Azure Synapse, Azure SQL Manager Instance, I believe. So I'm sorry, I will let you, continue there, Anna. I'm taking.
Yeah, no, I think you summarized it really well. We talked about learning Azure SQL Database through demos. So we looked at deploy and configure, and then we looked at the meat and potatoes. So performance, security, and availability, and hopefully everyone learned something new. And I'm happy to take any questions now or later, or I'd love for you guys to get hands-on with this stuff.
Yes, and one more thing is also thank everyone for making the time and being here with us today. And remember and I will add to the comments below the resources that were shared by Anna, not only the the Learn section, right? I believe it came from Microsoft Learn, right?
Yes.
Anna. All right, so that Learn section, inside of that Learn section, I believe that even if you do not have an Azure account, you're going to have an ability to use the resource that they have, labs that allow you. Is that correct?
Yes, they are free.
So folks, there's absolutely no excuse not to try. And this video here helps you to come back and reinforce of the exercise and concepts covered on the learning. And couple that, you can go check out also the channel for Anna here that covers additional information about it, and every Wednesday, I believe.
Yes.
So every Wednesday you can capture a new feature and or capability that is and more that is covered there. So do not hesitate. This is a great opportunity for you to learn. If you're in a budget, there's no excuse there. It's really you just making the time and executing, folks. Let me take a look at any more questions. Do you want to say any final thoughts, Anna?
No, just thank you so much for letting me come speak to you all. I really appreciate your time. I know there's a lot of things you could be doing besides doing this, so I appreciate it and would love to connect on any platform. Thank you.
All right, folks. Thank you all very much. Again, thank you, Anna. And we're going to bring this to an end here. Really appreciate all the time. And make the best, folks. If you're not able to see the entire video, remember you can come back and the video will be posted here on the channel. It is free for everyone, along with the resources shared by Anna. I'll be updating the description and posting that is available to all. Thank you very much. You all have a great night, and see you all on the next presentation. Bye-bye.